Hello, Yuma. High school geometry classes. Back to it. Let's see how this goes again. Today, we're looking at Pearson Tech Section 11-2, so you can follow along in the book if you like. What we're going to be doing today is talking about prisms and cylinders, and more specifically, how do we find the surface area of prisms and cylinders? All right, so first we're going to answer the question, what is a prism? What do we need to know about them in order to find the areas of the surfaces? Same questions are going to apply to cylinders, all right? We got a ton of vocab too to go with it. We're going to talk about prisms and their various parts, okay? Bases, lateral faces, what's an altitude, what's the height, then what's a lateral area, and then what is the total surface area. We're going to differentiate between a right prism and an oblique prism, and then we're going to do the exact same thing for cylinders, okay? So let's get into it. All right, a prism is a polyhedron composed of two parallel congruent bases, and they'll be connected by parallelograms called lateral faces. All right, so for our prism today, for our example, I have chosen a pentagon. All right, and I am going to flatten it out. So what you need to do is kind of visualize that I'm not just scrunching this down. What I'm doing is I'm laying it flat on the table. And let's see if I can do that. There we go. So we've just laid it flat. All right. And now, again, for a prism, I need two of them. So I'm going to duplicate that baby. I think. Come on. There it is. And put another prism in another plane parallel to it. Now I want you to know that it doesn't have to be directly above it. It can be anywhere. All right. That, for example, could make a prism. Let me make some straight lines that are going to connect those, and you are going to see, oh, that didn't do what I wanted it to do. Try again. All right, straight line. Let's make them red. Okay, that connect. Ooh, this is not going to be as easy as I thought. You know what? Let's try this little tool here. See if that's going to work. I connect that point. Still didn't work. Dang it. Alright, Minardi, let's keep the pen in place. Connect those. Good. Connect those. Good enough. Connect those. Good enough. Finally connect those. Alright, so hopefully my picture is not too terrible there, and you can actually tell that what we've got is a prism that is two parallel bases, both pentagons, and then each of these sides, all right, made from parallelograms. So you can see right here, I'm going to color that in a little bit. All right. That would be one of the sides. It is a parallelogram. We would have another one here and several others, right? In this case, we're going to have 5 faces that make up the lateral area of the prism. Okay, so this is what we got. We got 2 parallel bases connected by parallelograms. All right, in this case, what we've got is what I call an oblique prism, which means it's not made from right angles. And again, you see the parallelograms that are formed to make the right angles. Let's get you to some prettier pictures. Maybe this is going to help. All right, so an oblique prism, what we got right here. All right, once again, those angles are not right. The top base is not situated directly over the lower base. That's called an oblique prism. On the other hand, what we got here is a right prism. Every one of these is a right angle, all right? And therefore, the top base is directly above the lower base, okay? In this case, the lateral faces are going to be rectangles, not merely parallelograms, okay? So let me reset that to the way it was and make sure we've got our vocab set. So bases, all right, here and here. Lateral faces, 5 of them, all around the sides. there, 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 come on, okay, and then 2 more somewhere that we're not seeing. Okay, 5 lateral faces, 2 bases, okay. I need you to notice also that just because we lay it on the side, we still have bases here and here, but the lateral faces now are these around the sides, right? Okay, when we come to doing calculations on them, we need to be able to picture this as the height when our parallelogram or when our prism is set on its side. All right, so does that kind of make sense? So I hope everybody's seeing how this is going to work. Okay, so let me check on our vocab. Did I miss anything? We've got bases, lateral faces. All right, cool. Now, the height of a prism. Okay, let me first start. If I draw a line straight down from a vertex to a line that's parallel or an extension of the base, the plane of the base, and those lines are perpendicular, of course, that blue line is called an altitude. Okay. Its length is h, and that equals the height. Okay. So I need you to know that because later on we're going to talk about this length here, which is different than the height. Okay. That is going to be called a slant height. Okay, we won't worry about that for a couple units yet, but I need you to make sure that when we're doing these calculations involving height, we're always taking that perpendicular altitude and using that for the height of the prism. Okay, so on an oblique prism like this one, don't get it confused with the slant height. On a right prism, we don't have that problem. There is no slant height. The height is simply the parallel, the perpendicular distance, okay, from the base to the base. Okay, so we got altitude, we got height. Now we're going to talk about surface area and lateral area. So our questions for today involve how do we go about finding the surface area of the prism? Well, the surface area of the prism is going to be the sum of the areas of the 2 bases. So it's like we're painting the outside of this, right? We'd have to paint the top, and we'd have to paint the bottom, and then we'd have to paint each of the 5 outside surfaces, okay? So the 2 bases plus what we call the lateral area. That would be the area of this case, in this case, of the 5 lateral faces. All right, lateral faces. All right, so the lateral area, and the surface area is going to be the sum, again, of that lateral area plus 2 bases. So let me reset this here. Okay, so we're going to write that the surface area equals 2 times b, where b is the area of the bases, okay, plus the lateral area. Okay, now I want you to notice something. We can take the lateral area by doing all 5 of these rectangles or parallelograms. If it's oblique, there's 1, there's 2, there's 3. We can do all 5 of them and add them up together, right? But all of them are going to follow the formula for the area of a parallelogram, which is base times height, right? And I'm using little b to mean the length of that one base. Then here's another base times the height, and another one, and we add those all together. So in the end, what we're doing is adding up the 5 bases, B4, B5, okay, if you can read that, all times the height. So what we end up with, now, base 1 plus base 2 plus base 3 plus base 4 plus base 5 is the perimeter, correct? So we can change our formula to read that the lateral area is equal to the perimeter times the height, meaning that in the end, we come up with a formula that says surface area for a prism is 2b plus perimeter times height. That cool? All right. Now in some problems down the road, I just want you to be aware of this, we may be doing some problems, say, involving a weird shape where I've got a pyramid stacked on top of this, okay? In which case, we don't want to consider the area of this base right here, right? It won't be part of our surface. It's going to be hidden under that pyramid. This is why we need to draw that distinction where sometimes we're going to be doing problems involving surface area where we only use parts of these. In this case, I would use only 1b for the bottom plus the perimeter times the height plus, in this case, whatever we were going to find out later about the surface area of the pyramid. Okay, so just important to me that you recognize that not all the time are we going to use every single one of these, both bases, all the perimeter. Sometimes we're going to have problems that form exceptions to the rule, okay? All right, but in general, we're going to talk about the fact that the surface area of a prism is going to be equal to 2 times the base plus the perimeter times the height. Now, you'll also see this is why it's so important, that last unit that we did in figuring out areas of polygons. Okay, so it's going to be crucial that we remember how to find, in this case, the area of the pentagon. Okay, so remember that from the last unit. We're going to need to find the central angle, cut it in half, do our trig, whatever was taken to do that last unit that we all were so good at last time. Okay, next, same kind of story is going to apply to cylinders. All right, a cylinder has a circular base. Okay, and so here's a circular base. Here's an oblique cylinder, still the same 2 bases. Again, the circles, the bases are parallel and congruent. Okay, once again, they can be laid on their sides and still have the same kind of formula. We still look now at these bases as being here and the height as being the distance between the bases. We still have the same issue with an altitude for an oblique cylinder. Okay, so nothing else really changes here. What does change is the formula for the surface area of a cylinder. We're going to use the same thing, surface area equals 2b plus the lateral area, but in this case it makes it kind of easier, right? The area of the circle, the area of the base, is pi r squared, right? Now, when we fold out the lateral area, so if you pictured like a net, here's a base, and we've got this sucker connected by a parallelogram, like having just unfolded this guy, right? And its area is still base times height when we talk about the base, little b, little base of the parallelogram times the height. Well, check out what b is equal to. Since b is totally attached to the circle here, to the base, little b is going to equal the circumference of the circle. Not like the perimeter. See, back before we did perimeter, right? Now, we're going to realize that the lateral area, in this case, is the circumference times the height, which boils us down to a nice simple equation that the surface area of a cylinder is equal to 2 pi r squared for the 2 bases plus the circumference 2 pi r times the height. Now we have something fairly simple. Okay, once again, we're not going to use every one of those components, but for a cylinder in and of itself, the area, the surface area, is 2 pi r squared for the bases plus 2 pi r times h for the lateral area. Okay, so I hope that gets us going. I hope that doesn't make us stress too much. It's not that terrible. We'll work on some of this stuff in class tomorrow. So I'll see you then.